So first we go through the why this is a global sleep crisis. 2 billion people around the worldwide, they have the sleep deficiency about the WHO. And 40% adults, they just sleep less than 7 hours, and it can cause like 680 billion around non-productivity. So they have very hard to make the decision making, and their cognitive ability is like disintegrated. And there is a no device FDA approved which can do the brain computer interface. And how to say, there's so many devices they can track the sleep, but they cannot modulate. And there's some another things we have some solution like a sleep trackers, like so many watches and everything. They can track the devices, but they cannot modulate, and they cannot enhance the productivity. And we have the sleeping pills to how to say for the sleep disorder. But most of the sleeping pills, they just reduce the cognitive ability, and they can give the drowsiness when you are wake up. So and neural activity is not enhanced. I think it's most of the time is diminished. And there's another CBTI technology which is non-invasive, but it's a long-term treatment, like 30 weeks, and maybe some people take the 1 year to take this treatment, but this is very slow, and some people can have benefit by this, but most of not. So DreamLink, we just make the first closed loop during modulation. So when you are sleep, and I will go through how can it sense, decide, and modulate in future. So our DreamLink product, which is like a smart pillow, and it has the occipital BCI and closed loop modulation. So I go through it's a occipital EEG sensing. Basically, it's a dry electrode in the pillow, and it captures all the waves from the O1 and O2, which is the backside of the sensors from the occipital cortex. And we have the closed loop architecture, which in the real time is sense and decode on the same times all the sleep things, and it will decide and modulate the pipeline in 500 millisecond latency. So, and it's a multimodal stimulation. It have the acoustic, binaural beats, and olfactory, and TACS and TDCS. So it's simultaneously is just induced. And we have the AI engine which just calculate your sleep during the, how to say, when you are on the pillow. So why this occipital BCI is required for the sleep? Because there are so many devices which you can wear on the head, and it collect from the frontal cortex, the signal. But our device is just, you just have to sleep, and it just make very easy. So first one is we just calculate the alpha power biomarker. So occipital cortex is very important when you sleep, and on that time, this alpha waves is 3 times much more than the, how to say, from the frontal part. So it can initiate your sleep, and on that time we can easily find by the O1 or O2. And second is the visual cortex inhibition. Like when you close your eyes, so on that time the occipital cortex is directly connected from your eye, and is this, how to say, enhance the alpha power. And it's easily detect like people are going for the sleep, and is changed to the N1. And the third one is our pillow form advantage. You don't need to wear the headband. It's just directly you just go, and our sensors which is 1020 system like O1 and O2, they just placed, and mechanically they can start and sensing the sleep. And fourth one, the spindle and delta rich zone. When you are asleep, on that time on a N2 and N3 stage, there's a high activity of the N2 and N3, so they easily detect the slow wave sleep and how to say, our model like enhance the activity. So occipital cortex, as we target for this BCI. So what is the rationale behind this? Like we have robust signal quality, like high amplitude sleep oscillation, and there is a no, how to say, muscles activity. So we have signal is very clear, how to say, it is not diminished. And alpha rhythm axis is 3 times higher than the from the frontal part. So we can detect the when the sleep start and is reached to the like N1 stage. And we have the slow wave activity, like occipital cortex reflect like homeostatic sleep. And when we sleep, the pressure sensors, it just, how to say, sense, and closed loop is start. And it's just, and how to say, our electrode placement is just like embedded and has improved the quality. So we have this key sleep EEG markers when this neuromodulation start, basically on the delta phase when you have the N3 slow wave sleep. And it's very important for the, how to say, memory consolidation. And theta, which have the RAM and N1 stage, and it can replay your hippocampal memory. And how to say, and it's during the dream or REM stage, you can encapsulate the much more memory and cognitive enhancement. And alpha, which have the like pre-sleep duration, when you start sleeping, the alpha waves is much more higher. And spindle during the N2 stage. So our how to say, pillow sense this spindle activity very quickly, and it's related to the thalamocortical connections. And the K complex, which is like very important for, how to say, when you are asleep on an N2 stage, is track your like when you have to awake or not. So on that time, the K complex play a very important role. So this is all is embedded on a dream link, like it's a, how to say, multi-intelligent pillow, and which have the occipital dry electrode like EEG on a O1 and O2, where you can sleep and easily sense the signals. And we have so many neuromodulation like acoustic, olfactory, TACS, and TDCS, which, how to say, during the sleep, they just, on a time being, they just modulate your sleep. And we have this AI sleep engine, which sends all the electric wave from the occipital cortex, and they just filter out the, and every stage they just capture and modulate on that time. And it's a real-time closed-loop adaptive modulation, like it's for the personalized for the people. Like every single people, they have their own brain waves, and it can simultaneously, when you sleep for the 30 days, it can adopt very easily. And our pillow have the, we have the design like ergometrically, where you don't feel very irritated, and it's just very comfortable. And we have the app which just have connect wirelessly, and you can, how to say, if you're not satisfied, you can check your modulation next in the morning, which one stage of your sleep is very well and which is not going very well. And maybe you can set the parameters, like when you want to, how to say, enhance your cognitive power, or you want to go on a deep sleep for this memory consolidation. So this is our pillow, which you can see on a booth. And now I talk about this closed loop neural architecture of this our pillow. And it's just like acquire the EEG signals from the occipital cortex, and it just sense. And on a 30-second approach, like it will give all the biomarker of the sleep, and it just decode all the sleep stages, and like N1, N2, N3, and REM stage. And it will also give the, how to say, K complexes and slow wave activity. And it will decide on that time, like which one stimulation the, how to say, the person need. and it will adapt within like 30 days, and it will modulate like auditory, SAND, and TACS and TDCS. So it's continuously neural feedback and resensing the whole night of your sleep, and it will stimulate on a real time. So let's go to the like each of the neuromodulation, how it works on our DreamLink, and we just give this 40 hertz binaural beats because we have the how to say speakers in our pillow, and we can binaural beats. It can be like a different like left ear and right ear, like it can different kind of the sound, and it will decrease and brain sense like it's a real thing. So we create like 40 hertz cortical oscillation, which is like promote the gamma band, and is entertainment associated with the REM stage, which is like very important for this memory consolidation. And we can also use like 40 and 44 hertz, like which is for the 4 hertz, and it is very important for how to say initiate the stage from wake to N1 stage, because in so many patients they have very difficulty to start the sleep. So these 4 hertz is very important, and they can get the sleep very easily when they go on a pillow. And another is the slow oscillation, which is like a phase targeting. So we put the like 0.7 point hertz of the stimulation, which is like phase locked, and it connect to this slow wave amplitude with the, and it will maintain the deep sleep on an N3 stage for the long time. And it's adaptive volume control, like when you sleep, and sometimes in the night it will can sound will start, but it will not disturb your sleep. So these are the like some scientific evidence, like we just collected on some papers, like where we how to say NGO et al. They just give the pink noise on an up state of the slow wave, and they found the how to say the memory is very good. Like they find the like it's a 36 or 26% they just enhance, and the neural beats they just do for the Herman et al. Like 40 hertz, and they just respond to the gamma entertainment is very well. And auditory stimulus timing on a N2 in N3 stage enhance the sleep spindle and sleep and spindle density very well. So the next is the olfactory stimulation and memory reactivation. So direct hippocampal pathway. So we have some olfaction, like you have some rose, lavender, and which sense you can stimulate. So the biology is this, like olfactory directly go to the hippocampus, and it can bypass the thalamic pathway. So it's and there's a research like Res et al. They just the study you like some people they give the order, and they just how to say in the night they just read and they find the location, and in the morning when they tested, so and during the sleep when they give this how to say sand, so significantly they just improve the memory, like targeted memory reactivation they just do. Like they remember the place, and they remember their own what they did previously. And they just also have this Dickman et al. They just review this consolidation theory, and they just find like targeted memory reactivation is enhanced by the scent. So there's so many scientific evidence that they just targeted by the scent, and they just find this consolidated memory and like personalized memory. And next in our pillow, we have the transcranial electric stimulation, which is like less than 2 milliampere, we just give by the electrode on the scalp. And it will do the neuromodulation during the sleep. And There's a basically we have two type of the stimulation, like transcranial alternative current, which is how to say simultaneously entertained with your brain rhythm during the night. So our target is N2 and N3, like which have the primary effect on during the memory, and spindle and slow wave coupling, which is very important for the memory consolidation during the sleep. And TDCS we just improve, which is in the initial stage when people cannot sleep, like insomnia patient. They just from wake to N1 stage they can go very easily. And they have the binding from the LTP, like long-term potentiation, so it just encapsulate for the long period. So now we go to the like transcranial alternative current stimulation, like how we induce by our flow. So it's a slow oscillation entertainment, like 0.75 hertz we just induce on the brain, and it's a sinusoidal current. And this oscillation enhances the upstate amplitude. So it's promoting the N3 depth and spindle nesting, which is, how to say, I will show you later how it's important for this memory consolidation. And it will also suppression the alpha stage, like TCS of the individual alpha frequency reduces the hyperarousal. So when we give the alpha state, so people cannot like hyper arouse, and they just go sleep very easily on an N1 stage, because alpha is very important for the when you go for the drowning state. This is the first stage when you go for the sleep. And this closed loop phase locking, so dream link, they can sense the how to say your brain activity, and it just modulate on the same time, like it will link with the phase and increase your how to say sleeping behavior. So we have two type of the entertainment, sinusoidal waveform and this frequency tuning. So during the sleep we can do the N3 slow wave stimulation, and in the beginning we can do the entertainment. So these are like our TCS phase locked cortical entertainment, like if you saw what first is do the phase detection, which is collected the sleep from O1 and O2, and it up state targeting. So when we have the slow wave, and it just induce the slow wave activity, and when it collected the spindle amplification, so it's just it will enhance the TCS power a little bit, and it's a synaptic consolidation, like when you have the spindle and slow wave together, so it will improve the memory transfer from your hippocampal to the neocortex. So basically in the clinical evidence, we just show the slow spindle power, they just increase like nearly 30% in how to say some world pair game, and 8% N3 sleep is increases, and 26% hippocampal neocortical memory transfer, it just increase. And our flow also deliver this phase delivery, but so I will go through here the phase, how to say this mechanism, like how during the sleep our memory transfer from hippocampus to the neocortical region. So it's a triple coupling hierarchy in a brain when we have this sleep. So this slow oscillation during the up state is here. You can see on a like figure A, where is the slow wave, and another is a thalamocortical sleep spindle, which is come through the down state, and there is some ripples from the hippocampus. So this hippocampus initially, when we have some memory, like during the day, so this hippocampus replay so many times during the sleep. And when this memory engram encoded to the neocortex, it just make some important bond in our neocortex, and this memory engram is attached. And this process during the, how to say, N3 stage, it just go like continuously, and thalamocortical and hippocampus, how to say, play very important role. Like when the slow wave oscillation occurs, so there's a uh, after inside the trough, there's so many ripples, not ripples, it's a spindle go through, and these ripples is encoded by the hippocampus to the. So these all mechanism is very important for the memory consolidation, and this is like our main target, and our pillow do the during the night. For this memory in consolidation. And another is transcranial direct current stimulation. So we have this anodal occipital TDCS during the NREM stage, which have increased the neural excitability during the sleep and enhanced the slow wave activity for this memory performance. And we have these two anodal and cathodal how to say, for this TDCS. So where the cortical excitability increased by the anodal and depolarization. So it's how to say, enhance the slow wave activity on an NREM stage. And cathodal, we just how to say, decrease the activity like a hyperpolarization, and it's just for initiation of the sleep. Like when you have the hyperarousal, like insomnia patient, they cannot sleep. So this cathodal, we just decrease the hyperactivity, and they just go for the sleep on an N1 stage. And these cathodal and anodal, they just simultaneously, how to say, sense and do the action by itself during the night. And this is a cortical priming and neural plasticity, which we have, how to say, connect from the scientific literature. So it's like NMDA receptor for the like TDCS, and influx the calcium ion, which phosphorylate the AMPA receptors, and it enhance the synaptic strengthening. And BDNF, which is like very important for this protein for sustaining the long-term potentiation. So it also increase, and the sleep consolidation window is just prime the synapses. And we also see that this clinical evidence outcome, like on a NREM, delta power is increased like 28%, and 0.5%, resting memory potential is just for the anodal we can constrain, and 2.1 BDNF protein activated during this sleep. And working memory enhanced 19% on this when we do some test. And this precision timing and ride modality on a ride phase. So this during the whole night is timing is very important, like when wake, N1, N2, and N3 and REM stage, which kind of the, how to say, stimulation will be occur. So so it's based on, basically it's based on the individual, like which stage of the sleep they have problems. So on that time, these stimulation occur. And this is our AI engine algorithm model for the sleep staging. Is collect the signals and pre-process, and this we use this transformer model for this how to say, for the AI engine, and it's just clear the 5 class of the sleep, like N1, N2, N3, and REM stage. And our pillow can be used for this some research application, or our institute too, like for the insomnia management, deep sleep, N3 enhancement, memory consolidation, and neurological research. We also use for the Alzheimer patient. And this is how to say, this is a whole our pillow which can do, and it's a intelligent closed loop monitoring system. Yeah. Thank you.